told that we could start with the first talk of the first track. I'm very happy to be here. My name is Henrich Poehls from University of Passau in Germany. I did my diploma degree in computer science from University of Hamburg back then. I also went to do a Master of Science in Information Security at Royal Holloway University of London. I'm currently a PhD student at the University of Passau and working in a just started project called Rescue It that has the general focus to help to build robust and secure supply chains, IT supported. I will not go into details in this talk what this does. This is basically something that came up in the questions that I had myself while preparing this project. The outline of today's talk would be that, back to the title maybe. We want to determine how or which data is actually covered by a digital signature, and we want to do this from an application level perspective. So just a quick motivation why we want this and where the problem actually lies. Then I will quickly introduce what the really simple and simplistic approach of BitFlip will do, and also give you some details what it is not doing, and all with the example of an attack that you're probably familiar with, which is XML wrapping, and I will wrap up the talk in a conclusion. So, as design and the design process in applications is layered, which is not a bad thing in itself, we have to deal with some differences in these layers. So on the application layer, you have your application logic written by the domain experts that actually do the processing of the data. Where does this data come from? In today's world of web services, you basically get your data from some messages that arrive at your system. And the application then does some clever parsing, XParse expressions, whatsoever, to extract the data it needs. The message probably arrived at your system and was going through some process, and these involve security processing. So the security layer can protect the message, or in XML, mostly the case parts thereof. And one examples are that you want to have a message signed, and you only after verification of that signature, knowing now that this purchase order whatsoever came from actually one of your clients, you want to give it to the app that then goes on with the product purchase or whatever. The problem here is that the layered security only works while you keep these two layers, application layer and the security layer, in a certain synchronization. You have to keep them in sync. So if you turn to XML and the SOAP message standard, you have a plethora full of mechanisms that you can use. The basic mechanisms for SOAP message are WS security. Then you have authentication tokens that allow you to authenticate your clients, or you have XML signature and encryption, which I won't talk about the encryption here, but you have XML signature. And you can mitigate most of the attacks. There are papers out there just recently that did a full survey over the web services attacks, and they basically come up with some good security practices. So first of all, if you get XML messages, you have to define how they look like. XML offers a great degree of freedom, and you want to minimize that freedom. So you have to define a really strict XML schema for your messages, which then also, of course, otherwise it's not helpful, needs to regularly be checked and validated. And only then, if this is actually a message that adheres to the schema, you will do the signature checking, and that also involves that you have to check the public key you're verifying with. And last but not least, there's something like WS security policies, which allow an application to specify which parts of a SOAP message needs to be secured, either signed, encrypted, or both. And you should also, in these security policies, the application should also state what exactly it wants to be secured. And there should not be more security or less security. Less security is bad because obviously then something isn't signed that your application expects to be signed. More security might lead to some attacks where you have a lot of keys exhaust memory and process power. But you can basically mitigate and defend against most of these threats. But attacks on real-world web services are still out there today. So I asked myself, why is this happen? And I came across a quote by Ferguson and Schneider that said, authenticate not just the message, but everything that is used to determine the meaning of the message. And quickly turning to one of those messages, this is part of the beginning of an XML SOAP messages. I know I've been heard that numerous times. It's bad to show XML in presentations, but, well, there is no way around it. This is a bad example, and I'll show you why. So if you talk about parts of a message, then you're talking about things like references, X-pointers, X-parse expressions. And this X-parse expressions here, actually, the X-pointer expression, reference is something that says, okay, we want to talk about the element that has an ID of 1. And you will find, or the XML parther will find this quite easily. This is this one over here. It's a SOAP body. Well, and if you then continue looking at this in more detail, you will find that the reference giving down here is actually a reference of the signature, an XML signature saying, okay, this part above here is signed. So where's the problem? Well, the problem is basically here, where you have another SOAP body, which, except for what is written between these NDS name tags, down here saying Evil Homer and saying something else up there, is another SOAP body. And of course, the first SOAP body, the blue one that has been signed, is inside a SOAP header. And a body inside a header makes no sense. So every schema validation would have caught this. Any schema validation would have said, okay, we only have one header and one body. Why are there two bodies? There are lots of things gone wrong here, obviously. But the signature verification on that one will succeed. He will find this and actually run the signature verification process over the blue one. And the problem here called XML wrapping is that an application programmer that has been told, okay, you get a message, there's some header, it has been security checked. Once you see the message, all the signature verification process, it can be run. You feed it into your Java digital signature verification method, and out comes true. So you think it's verified, and then you continue, and then next step is, okay, where is my name? Okay, it's in a body, in this envelope, and then you end up with saying, okay, I'm the application, and I'm now going to do something in the name of Evil Homer. By the way, this is taken from a colleague from Ruhr-Universität Bochum, named Michael Jensen, who's also working in this field. So how does BitFlip work? Well, BitFlip tries to give the application the possibility to observe what's going on the lower levels. The lower levels in this case are signature verification. So on the right-hand side, you have the document as is, as you got it in your application. You feed it into signature verification, it comes out that this will verify. Of course, the signature verification process will get keys and policies and whatever the signature verification process needs, it will also get. So, of course, verification succeeds. BitFlip now can introduce one control change, in this case not of a bit, but in the case of XML we thought it would be more helpful to do this on a character basis. In this case we will just flip the G and put a big A in it, and then we'll feed this into the same signature verification process as the right-hand side and look for the outcome. And if the outcome would be verified, that would actually mean that we can change something here, and the result is that this character is not covered by our signature process. So the signature process does not care if we change anything at this position in the XML. If the signature process would report a failure, so changing something there would mean that the signature verification fails, then the result would be, okay, somehow this character is involved in the signature verification process. So this character is covered. And that's as simple as BitFlip works. So back to the SOAP message in XML, running a BitFlip on each individual character in a row. Actually, we came up with this more colorful XML document. Ignore the bluish colors at the moment. Just think about the red and green. Red means that we actually got a verified, even we introduced a change, so this is not covered by the signature. And green means if we change something here, then signature verification fails, so this is somehow covered. And we used the some internals from the parsing process in Java and the XML signature tools in Java to come up with some more enhanced information on this, but that shouldn't be part of this talk today. So, going back to the two parts that we identified as a problem, we will see that running BitFlip on each individual character of the name Evil Homer will actually yield the result that this is not covered, thus an application should not rely on this name being digitally signed and all the trust that it used to defer from that verified signature. We as humans can actually, with this picture, see that something else is signed. An application will not be able to find that there's how the actual wrapping took place with BitFlip, but it will, if asking is the E, the V, the I, the L, the H, the O, the M, the E, the R, is anything of these characters covered, it will get the result. No, it's not. And if the application, as I said before, works by traversing the XML or extracting the data in a way where it says, okay, I have an envelope up here, I'll go to the body, then I go into some return hash and then find the name field, then it will actually extract Evil Homer, but asking BitFlip, it will get the information that none of the characters are covered. So quickly, what BitFlip does not and cannot offer. It's very simplistic, and it does not provide what I would call a positive verification. So we cannot be sure, and BitFlip gives no assurance that the parts that seem covered